Welcome to Yatimkhana and Madrasa Anjuman Khairul Islam's Pune College of Arts, Science and Commerce Camp Pune 1. Myself Dr. Arif Tamboli, working as Associate Professor in the Department of Electronic Science. Students, today we are going to study the topic which is called Amplitude Modulation Transmitter, Receiver and Wave Equations. So today is our target to study the transmitter used for amplitude modulation, the receiver used for amplitude modulation, and therefore the name of the topic is Amplitude Modulation Transmitter, Receiver and Wave Equation. So there are three different types of the waves. One is called information signal, that is also called as an baseband signal, that is also called as modulating signal. So that information signal is basically low frequency signal. So that wave equation we are going to study. Second wave, which is called as carrier wave. So for carrier wave, again there is one equation that also we are going to study. And after completing the process of modulation, there is one output which is called modulated output. So that also having one certain equation, so which we are going to study. So let us start one by one. So all of you know that very basic of the amplitude modulation. In amplitude modulation, there is one signal which is called message signal. This is also called information signal. This is also called modulating signal. And all of you know that the information signal is a low frequency signal. And therefore, this low frequency signal we are carrying with the help of high frequency signal, and therefore that signal is called carrier signal. So here you can see the sine wave very clearly, which is having very high frequency because the time between two adjacent positive peak is very less. Here the time between two adjacent positive peak is very long. So time and frequency are inversely proportional. So here very long time, less frequency, short time, high frequency. So this is your information signal, modulating signal, baseband signal, and this is carrier signal. And all of you know the definition of modulation. Once again, I am repeating here. In the process of modulation, so see this is modulated output. In the process of modulation, which parameter is going to change of carrier signal? If you are talking about amplitude modulation, amplitude of carrier signal changes. Amplitude of carrier signal changes according to instantaneous value of an information signal. So here you can see the modulated output very clearly, and in this modulated output you will observe that amplitude of carrier signal is changing as carrier signals amplitude, so as information signals amplitude increases, carrier's amplitude also increases. As information signal amplitude decreases, carrier amplitude also decreases. And in this way, this is called as your process of amplitude modulation. Only amplitude parameter of carrier signal is changed. Phase and frequency are not changed. And all of you know that we are never going to change any parameter of information signal because it is very secure information. We don't have to change anything about information signal. We want to carry or we want to transmit the information signal with the help of high frequency carrier. And in modulator of the carrier, in modulator of the amplitude modulator, the modulator circuit only changes the amplitude of carrier signal according to instantaneous value of an information signal. So this all of you know. Therefore here you see in this diagram I have clearly given this is your AM. AM means what? A means amplitude. M means what? M for modulating signal. M for modulating signal. Therefore, this is the amplitude of modulating signal. All of you know x-axis 2 Vp. This is amplitude of modulating signal. This is the amplitude of carrier signal. This is the amplitude of carrier signal. Now here, in the according to the definition of amplitude modulation, the amplitude of carrier changes according to instantaneous value of information signal. Therefore, you see here at a time t is equal to 0, at a time t is equal to 0, remember the amplitude of modulated signal at a time t is equal to 0, the amplitude of modulated signal, this is a modulated signal output, is equal to carrier signal, is equal to carrier signal. See here, This is the carrier signal's amplitude, this much, and here it is that much. So at a time t is equal to 0, it is there. Means in the beginning when the process of amplitude modulation start, this is there. But thereafter what happens? Thereafter, this amplitude of carrier signal changes according to instantaneous value of information signal, and this amplitude is going to increase and this amplitude is going to decrease according to instantaneous value of information signal. Therefore here what we have written, see here, AC is the amplitude of carrier signal. AC is the amplitude of carrier signal, C for carrier, A for amplitude, plus we have written EM. EM means, now next slide you will come. EM means instantaneous value of modulating signal. EM means instantaneous value of modulating signal. So that you will understand in the next slide. And in this way here, you can see this diagram very well, in which the arrow is marked and it is called as maximum amplitude here in the negative, maximum amplitude is here in the positive. So here, this is the maximum amplitude. Now, when you join all these positive peak, when we join all these positive peak, we will get our information signal. And there are two side bands in case of AM, upper side band and lower side band. Both side band carries the information. Remember, that is important. Both side band carries the information. See here, this signal is an information signal. So here you can immediately notice exactly this picture is over here. And how this you got it? By joining all positive peak of amplitude modulated output. By joining all positive peaks of amplitude modulated output. This is modulated output. And therefore, this diagram is called as envelope. Therefore, this diagram is called envelope. At the edge of the envelope, outer side of the envelope, if we join all positive peak or negative peak, at the edge of the envelope or outer side of the envelope, you will get your information signal. And this is inside the envelope, there is a carrier. Inside the envelope, there is a carrier, and this carrier is not having amplitude constant, it is varying. So this is the diagram here, and here is the minimum amplitude, it is shown over here. Here is the maximum amplitude. Same thing can be shown on the top side also, minimum amplitude, maximum amplitude, and this envelope, this is the envelope. Therefore, normally it is said that in conventional life, in day-to-day life, when we pass the information, by a speed post, what we do? We put the information inside the envelope. We put the information inside the envelope and then we post it. So our information is inside the envelope, but here information is outside the envelope, and here inside information is outside the envelope, and carrier is inside, the envelope. And in our day-to-day life, yes, in day-to-day life, envelope is a carrier, and inside the envelope there is information. So this is your electronic signal. So accordingly, we have to understand. Now let us go to the exactly how does amplitude modulated signal looks on CRO, cathode ray oscilloscope. And you can see here a very nice waveform of amplitude modulated signal is there. And what is to be understood here, again, according to here, again, if you join all these positive peak, you will get positive half cycle like this here. And then here, if you join all these peaks, then you will get here a negative half. So here you can say this you do it, and then like this you do it, so you will get upper side band. And here for lower side band, you do like this, come here, and then from this, like free hand, you have to join the points with the free hand, and then you will get lower side band. So this is a lower side band which is also carrying the information signal, and this is upper side band. If you join with the free hand all these points, then you will get one sine wave at the upper side. And here this is a carrier signal, and amplitude of this carrier signal is changing. Now let us proceed next. So here all of we know, we have already studied this block. So in this block, this is the modulator of what? Amplitude modulation. This is the modulator of amplitude modulation, and that is electronic circuit. And this circuit works according to amplitude modulation requirement. This circuit works according to amplitude modulation requirement. Means for this modulator, when you apply two signal, namely signal number one as an information signal, which is a low frequency, and signal number two as a carrier signal, then this modulator circuit only changes the amplitude of carrier signal according to an instantaneous value of information signal, because this modulator circuit is designed only for amplitude modulation purpose. And here output is your somewhat like this, means just one slide before only we studied that this will be the output. And then what we are going to do, the output of this circuit here, modulated output signal here. So remember, this modulated output signal is nothing but carrier signal only. Modulated output signal is nothing but carrier signal only, but amplitude of that carrier signal is change. But the amplitude of that carrier signal is change. And here this modulated output is given to the RF amplifier, radio frequency amplifier, and then it comes to the output. And now this amplified signal, which is having what variations in the amplitude, this amplified signal which is having variations in the amplitude according to instantaneous value of information signal, this signal is given to the antenna, and now antenna will convert this signal into electromagnetic waves and it will transmit. So this is a block diagram. Now we have added here what? Antenna. So here antenna is added, and therefore this becomes a simple block of amplitude modulation transmitter. And now we are going to detail slowly. Here again, this carrier signal is generated by what? By radio frequency oscillator. So just here we have written carrier signal and applied as a high frequency sine wave. But which circuit generates this? Radio frequency oscillator. So here you can see that this is the RF oscillator over here, and this is baseband signal, and this is a modulator in, and this modulated output is here modulated signal, then RF power amplifier, and then antenna. So antenna will convert this modulated signal, okay, which is having varying amplitude. And here normally input signal, that is information signal, is nothing but voice signal of a human being. So there is a microphone which converts voice signal into electric energy. There is one more amplifier, and then it is given to the modulator. But information signal is nothing but low frequency signal, and there is one sine wave generator which is called high frequency sine wave generator, that is carrier generator. And then this is a modulated carrier. This is very important. The output of modulator is carrier signal, but amplitude of that carrier is changed, and then it is again amplifier and then to the antenna. So now this sine wave block we are going to just replace by we are replacing by RF oscillator. So it is so simple. But now we will not draw every time the circuits like this. We will draw the block diagram. So here AM transmitter block diagram. So this is the AM transmitters block diagram. So sound waves, information signal. So you have to say that there is a microphone. There is a microphone, and you have to write sound waves, that is the information signal. So microphone converts that sound waves into an electric energy. It is given to the audio amplifier. Then it is given to the modulator, and modulator is having two signal. Number one, information signal. Number two, carrier signal. And here there is oscillator, this carrier wave generator, and this is nothing but RF oscillator. So here you can see this is RF oscillator. Now modulated output is given to frequency filter. Modulator output is given to the frequency filter. Here there is a new block. Why? Because unwanted frequencies we want to remove. If any noise frequency is there, then we want to remove that, and that is what here frequency filter it is there. So here next block is the amplifier, next block is a power amplifier, and then it comes to the what? Antenna. So this is connected over here. So this is coming to the antenna, and then it is going to convert that waves into electromagnetic waves. So here red signal you see. So in this way, this is again a general block diagram of AM transmitter block diagram. Now next block you will try to understand. So here this is the amplitude transmitter. Now in this transmitter, in this case here we have understood every block, Microphone is used to convert the sound waves into electric energy. Audio amplifier, modulator. This modulator is only changing the amplitude of carrier, and then it is giving to the filter circuit, amplifier circuit, and then power amplifier, and then like this. So this is the transmitter, and you have transmitted the electromagnetic waves. You have transmitted the electromagnetic waves. Now on the receiving side, means here amplitude modulation receiver. On the receiving side, what should be there? There should be one more antenna, and that antenna will catch the electromagnetic waves of that particular frequency which you transmitted, of that particular frequency which you transmitted. Therefore, here this antenna is designed for a particular radio frequency. It will catch that only radio frequency. It will catch that particular radio frequency. But if you use the tuning, if you use the tuner circuit, the same antenna can be used for catching different radio frequencies. And therefore, here tuner is not shown. So you just try to understand that here this antenna is standard antenna of which is catching specific frequency. And these frequencies are what? Radio frequency. This radio amplifier is there. So antenna converts that radio frequencies into electrical signal, because antenna is what? Antenna is electric to electromagnetic converter, and vice versa, electromagnetic to electric converter. When it is converting that signal into electric signal, it comes to RF amplifier, radio amplifier, and then it is given to demodulator circuit. Then it is given to demodulator circuit. Now here is our point of interest, what the demodulator circuit is doing. Now, in this block diagram, again there is a local oscillator shown, and then you will get confused that is there any parameter change of this local oscillator like a modulation process? So no. So here, now you don't worry about this. This block I am going to explain you later on. So this demodulator circuit will take it here only, and demodulation means what we'll study means collecting the original information back. Demodulation means collecting the original information back from and signal where the amplitude is varying with respect to time, from and signal where the amplitude is varying with respect to time. And this demodulator circuit is doing that job. How it is doing, we'll see in the next slide. And here this output is given to the baseband amplifier, that is the local amplifier, and then it is given to this. So you just simply understand this block. This I will come to later on. So now we'll go to the one more block diagram which is very much simplified. Now see here, as I told you, this is our antenna, and here electromagnetic waves. So in this case, here you'll understand that this antenna is catching the electromagnetic waves from free space. From free space. Here electromagnetic waves are not shown, so little bit confusion. Here electromagnetic waves are shown, so it is understood that antenna is converting these electromagnetic waves into electric signal. And here this block is shown. Here this block is shown, and this block is called RF tuner, radio frequency tuner. You are going to tune to the various radio stations, Pune Vivid Bharati or any other. So when you are going to tune to that particular radio station, 455 kilohertz or something other like that, then you are going to use one circuit, and that name of that circuit is tank circuit. Name of that circuit is tank circuit. So this tank circuit consists of inductor coil L and variable capacitor C. Inductor coil L and variable capacitor C. And frequency of generated by this tank circuit is given by the formula F is equal to 1 upon 2 pi under root LC. F is equal to 1 upon 2 pi under root LC. So if the frequency of this tank circuit matches to the frequency of the electromagnetic waves, frequency of this tank circuit matches to the frequency of that electromagnetic waves, then this antenna will catch that particular electromagnetic waves. Then this antenna will catch that particular electromagnetic waves, and this block is not shown over here. After antenna, there should be tuner circuit, T-U-N-E-R. There should be tuner circuit, and then this output of the tuner circuit is given to RF amplifier. And then RF amplifier's output is given to the detector, that is demodulator circuit. And in case of amplitude modulation, you will understand now, in case of amplitude modulation, the detector circuit is very simple, and that detector circuit is simple half wave rectifier. It is a simple half wave rectifier. So we'll see that. So this is a detector circuit, and after detecting that signal, then it is given to the audio frequency amplifier. It is given to the audio frequency amplifier, that is called AF amplifier. Now this output, if it is not further amplified by the power amplifier, you cannot drive the loudspeakers of higher wattages. So you can only listen with the headphone, because headphones are having very less power loudspeakers inside that. This is the headphone. So this is headphone connected. But if you want to use for a what large gathering, then you must use power amplifier, and then loudspeakers can be connected. Now this is a one very simple block diagram wise understanding of AM receiver block diagram. But here there is one problem. The problem is what you see here. You are going to tune to a particular radio frequency by changing the frequency of tank circuit, and how do you can change the frequency of tank circuit? There is a variable capacitor. So you change the value of C, the frequency of tank circuit will change. F is equal to 1 upon 2 pi under root LC. And here the problem comes what? When you catch one particular radio frequency by tuning the circuit, then nearby that radio frequency, suppose 455 kilohertz one radio station is there, then nearby that frequency, if there is a 450 kilohertz another radio station, or 440 kilohertz there is another radio station, then some electromagnetic wave signals are going to interface with this radio frequency which you are catching, and therefore you are getting noise. Therefore here see the title, AM receiver block diagram without RF to IF converter. Without RF means radio frequency, IF means intermediate frequency. That you will understand next slide. So here that problem is there, and this also tuner circuit along with antenna is called radio receiver. This tuner circuit along with antenna, tuner circuit is nothing but LC tank circuit, along with antenna is called radio receiver, and this radio receiver is very basic radio receiver which is called crystal radio receiver. So it catches one particular radio frequency, but along with that the neighboring radio frequency noise get interference with this, and that is the problem. Therefore you want particular that radio frequency only, and you want to reject all other radio frequencies. You want one particular radio frequency and you want to reject all other radio frequency. So here one logic is used, and that diagram is 100% is used. This is just introductory diagram, and that diagram is what we'll see here. So this is that diagram. AM receiver with RF to IF converter, AM receiver with radio frequency to intermediate frequency converter. Now what is in this diagrams here? This block will be same. What antenna is there, and in that antenna RF tuner is there. So here RF tuner section. Now we have converted that diagram here. This LC diagram we have converted into a square block, because if you write simple RF tuner section, it is understood that there is one tank circuit, LC circuit. So you have to go block diagram. So here it is understood that this is antenna catching the electromagnetic waves. This block is called your RF tuner section. And now after RF tuner section, here there was direct RF amplifier, but now here there is no RF amplifier. RF to IF converter, RF to IF converter, radio frequency to intermediate frequency converter, and this is also called as mixer. Now actually speaking, this is not doing the job of mixing, but it is called mixer. In fact, it is doing the job of separating one particular frequency from all other frequencies. This mixer, in fact, it is doing the job of what? Separating one particular frequency, or selecting the one particular frequency and rejecting all others. So here, for every radio frequency, say suppose 455 kilohertz is one radio frequency, and there is one more radio station at 440 kilohertz. Then there is one circuit. What it is doing? It is catching the radio frequency of 455 kilohertz and converting that radio frequency into corresponding intermediate frequency. It is very important. You don't simply say that the RF to IF converter converts radio frequency into intermediate frequency, because for every radio frequency there is one corresponding intermediate frequency, and therefore when it is doing that job, automatically this circuit will reject all other frequency. And when it is doing that job, converting of that particular radio frequency into corresponding intermediate frequency, then that particular circuit will automatically reject other, and your interference will be removed. And that is why this circuit is very important. But to do this job, so their circuit becomes complicated. Why? Because your selection is what? Your selection is of one particular frequency only, and you want to reject all other. Therefore, to convert radio frequency into corresponding IF, the job becomes complicated, and therefore what you will require, you will require one local oscillator. You will require one local oscillator along with this RF to IF converter, because this RF to IF converter cannot do the job of converting the radio frequency into intermediate frequency without local oscillator. And this local oscillator circuit is used to convert that. So RF oscillator and local oscillator, and that is what I said here in this diagram. You just now don't get this, what is doing. Is it again going to change any parameter? No. Now input is here, RF, and that RF is converted into corresponding radio intermediate frequency. That RF is converted into corresponding intermediate frequency, because for every radio frequency there is a standard value of intermediate frequency. And if you do that conversion, then all other frequencies catch by the antenna of the nearing radio station, that will be rejected. And this is the job of this RF to IF converter along with local oscillator. And then the block diagram is very simple. After this block, this up to this it was there only. So after this block, here it comes again IF amplifier. IF, now it is not RF amplifier. Why? Because RF is converted into corresponding IF. RF is converted into corresponding IF. Here you see, here there is RF amplifier after tuning, of the particular radio station, because that is RF frequency, radio frequency. Here, RF to IF converter, when you use, the output of that block is intermediate frequency, and this intermediate frequency is corresponding to the radio frequency which is catched by the antenna, and here it is called IF amplifier and filter. IF amplifier and filter, of course, frequency filter. If any noise is there, it will be removed, because noise is having its own frequency, and it is there. So here this output is given now to AM detector, means AM demodulator. AM detector and AM demodulator, it is also called as AM detector and demodulator. And then after detecting that particular information signal, AM detector is detecting the information signal, and it is given to additive amplifier. Then additive amplifier's output is given to power amplifier to drive the high wattages loudspeakers. And this is the final block diagram of AM radio receiver, it is called, or AM receiver is also called, with RF to IF converter. And here you will get excellent selectivity. Excellent selectivity. You are selecting one particular channel only, and nearby radio station channels noise will not get incorporated, because this RF to IF to converter will reject all other frequencies and will convert your selected or tuned radio station frequency into corresponding intermediate frequency, and thereafter it is IF amplifier, and then the process is simple. Now we will focus on this, what? AM detector and demodulator. What is this exactly? AM detector and demodulator. So here try to understand now. Diode is simply used as AM detector or demodulator. So in this diagram, again you see here antenna is there. Now what is the antenna is getting? The input of antenna is our amplitude modulated signal, where the amplitude is varying continuously with respect to time. Here see, this antenna is getting electromagnetic waves of what signal? Our transmitter signal. Transmitter is what? Our transmitter is this. So here see this transmitter, input of transmitter is what? A carrier signal where the amplitude is continuously varying and it is converted into electromagnetic waves. And like that here now, as soon as you come to this point, you will understand that our and receiving antenna will get that waves, and it will get what? It will catch that if your this tank circuit, see here the tank circuit is given L is this side and C this side, and there is no variable C, means it will catch LC is fixed. It will tune only one radio station because you cannot go to the variable capacitor here. There is no variable capacitor. And in this way here, this energy is transferred to this side and there is one more capacitor. So this is nothing but our, yes, this is very simple. Upper block, you see here, this RF tuner, it is a radio frequency tuner. So here you can just remove this block and write down directly as a what? Radio frequency tuner, and only show the antenna like this, radio frequency tuner. So here, now output of that is given to here, see, now here it will come to the mixer and everything. But now here, after completing the mixer, let us see here, after output of mixer IF, if you come, this is the diode, and diode is doing the job of what? Detecting the information signal. So that you will understand in the next slide. So half wave rectifier it is there. Why it is a half wave rectifier? You will understand that. Then there is a resistor, there is a capacitor, and this combination of diode, resistor and capacitor, which is in half wave rectifier, diode, resistor and capacitor, which is in half wave rectifier, is called diode demodulator or envelope detector, because our information is what? Edge of the outer side of the envelope. Now this you will understand here clearly. See here, AM wave, amplitude modulated wave is this. What is this amplitude modulated wave? Amplitude is changing with respect to time of carrier signal, that is high frequency signal. Now there are two sidebands, upper sideband and lower sideband. And when you apply it to the rectifier circuit, all of you know what the rectifier circuit is doing always? Converting AC into DC. Converting AC into DC means what? In half wave rectifier, there is a positive half cycle, there is a negative half cycle. But negative half cycle does not appear at the output of half wave rectifier. Very basic of electronics, half wave rectifier input is having positive half cycle, negative half cycle. Output only positive half cycle will come. Negative half cycle not, because negative half cycle is the voltage which is going in minus, and rectifier want output to be positive only. That is called AC to DC converter. And here this entire negative envelope below x-axis, remove, see here, this entire negative envelope below x-axis will be removed by the rectifier circuit, and only envelope above x-axis will come, and only the envelope above x-axis will come, because the rectification process is done and negative part is removed. Now when it is coming over here, you can see your information signal is here. Now this you want to remove, and that is done by envelope detector, and that is done by envelope detector. Now this is also very simple. In this signal, you can understand, in this signal, this is outer side of that envelope. Now only a half portion of the envelope is remaining. Outer side of the envelope is your information when you join all that points. And this signal is a low frequency signal. This signal is a low frequency signal. Inside the envelope, there is a high frequency signal. Inside the envelope, there is a high frequency signal. Now you want to use one filter. You want to use one filter which will pass only lower frequencies to output. It will pass only lower frequency output, and higher frequency will be blocked or bypassed to the ground, and higher frequencies will be blocked or bypassed to the ground, and then you will get this information. And very simple, systematically it is done here. See this capacitor. Now this capacitor, when it is getting at the input higher frequency as well as lower frequency, all of you know this capacitor passes high frequency and blocks low frequency. Therefore, when high frequencies are there, they goes through capacitor to the ground, and low frequencies are blocked and they will go to the output. And here in our envelope only, outer side edge is nothing but low frequency. So this low frequency will go to the output, and high frequency will get grounded. And therefore, this is a role of what? This capacitor is very important, and it is called envelope detector. This is envelope detector. And this diode, what it is doing along with resistor? Diode along with resistor simply removing the negative part, means below x-axis. Simply removing the negative part means below the x-axis. And in this way, the amplitude demodulation circuit is very simple to understand. It is simple half wave rectifier. It is simple half wave rectifier, diode and resistor are doing the job of removing the negative part, removing the negative part, because in half wave rectifier negative half cycle is not appearing at the output. Same thing is here. And envelope detector means your capacitor is passing only lower frequencies to the output, and all this higher frequency carrier wave will get all this higher frequency carrier will get bypassed to the ground, and in this way you are getting information signal at the output. So it's very simple, and therefore now a very common radio receiver which is called antenna is required, no doubt, to catch the electromagnetic waves. RF amplifier is there. Now this antenna along with tuned circuit, it is understood. This is the RF amplifier. Now it is given here to RF to IF converter. This is RF to IF converter. It is called analog mixer. In fact, it is not. It is separating the radio frequency and converting that radio frequency into corresponding intermediate frequency. But here it is said as a mixer, doesn't matter. And to that mixer, local oscillator's frequency is applied, because without that frequency, you cannot generate intermediate frequency. Without that frequency of a local oscillator, you cannot generate the intermediate frequency corresponding to radio frequency catched by the antenna. Without this local oscillator, you cannot generate intermediate frequency corresponding to radio frequency catched by this antenna. And after this, you will observe no RF, there is IF only, intermediate frequency amplifier, then demodulator, that is a detector which you have studied, half wave rectifier, envelope detector, and then it is given to audio amplifier, and then it comes to the speaker. So in this way, this is nothing but a block diagram of amplitude modulator radio receiver. Amplitude modulator radio receiver. Each block is having its own function. Each block is having its own function. And here, therefore, diode used in rectifier circuit along with resistor is called demodulator circuit. But remember, only negative half cycle is removed by diode and resistor, and high frequencies are removed by capacitor. High frequencies are removed by capacitor. And in this way here, high frequencies are removed means how it is removing? It is passing to the ground, means higher frequencies are short circuited, and low frequencies are not short circuited. It is passed to the output. It is passed to the output, because this capacitor is vertical, parallel to R, parallel to R. Now this is general block diagram, and with this now we'll conclude that you have understood radio receiver, that is called AM radio receiver. Now it is very simple. Next part, all of you know that your information signal, baseband signal, is nothing but sine wave and low frequency sine wave. So what is a sine wave? Sine wave is a representation of voltage versus time. Sine wave is a representation of voltage versus time. So on this x-axis you will take a time. Now here, if you talk about angular frequency, if you talk about angular frequency, so x-axis there is a time, and what is the relation between frequency and time? F is equal to 1 by t, or t is equal to 1 by f, inversely proportional. But this time, if you replace with a what? Angular frequency. Angular frequency is omega. Omega is equal to 2 pi f, and here instantaneous amplitude, say amplitude plus and amplitude minus. So sine wave starts from 0 degree, then 90 degree, then 180 degree, one positive half cycle is completed, then negative half cycle starts 180 and then 270, and at 360 degree one cycle gets completed. This is Vm. So we'll not talk about Vm, we'll talk about amplitude, Am. Am means A means amplitude. So this is your amplitude. A means amplitude, and amplitude of modulating signal will write as a Am. Okay. So this is the representation, and therefore now let us see here. Any sine wave will be represented by the equation Em. Why Em? M means modulating signal, suppose. E means instantaneous value, because here for sine wave at every time the value of voltage is different. The value of voltage is different, and therefore it is said that Em means instantaneous value of modulating signal is given by equation Em is equal to Am. A is amplitude of modulating signal into sine omega t. omega t, but instead of omega only we have written omega m, m suffix. Why? Because this is the omega angular frequency of modulating signal. Therefore, omega m into t plus phi. Phi is nothing but angle. Therefore, here same equation I have written again here, and here only instead of omega we are substituting 2 pi f, because omega is equal to what? 2 pi f. So I'll show you this. Omega is nothing but 2 pi f. So see here, we know that omega is equal to 2 pi f. So for omega m, omega is angular frequency of modulating signal is equal to 2 pi f. Fm will come. M means modulating signal, frequency of modulating signal. So this is very simple. Only suffix we want to write down for that particular thing, because we are dealing with three waves. Wave number one, information signal. Wave number two, carrier signal. And wave number three, modulated output. Modulated output. So be precise while writing this. Em means what? Instantaneous value of modulating signal is equal to am, amplitude of modulating signal, into sine omega mt plus phi. Omega mt plus phi. And here you see am is nothing but amplitude. Omega we have converted into 2 pi f fm, and this is the frequency, angular frequency. Omega is the angular frequency here, and this phi is nothing but angle, that is called phase. Angle is also called as phase. So and this frequency along with this entire component comes as a angle. So here frequency is equal to rate of change of angle. Rate of change of angle. So here see, rate of change of angle, that is called frequency. So here in amplitude modulation we are not dealing with phi, and we are not dealing with phi because in amplitude modulation we are only changing amplitude of carrier signal. We are not changing angle. Therefore, what our equation will be get very simplified. We'll remove this phi. We'll remove this phi, and then we'll come to that equation. Em is equal to, Em means, again I am repeating, instantaneous value of modulating signal equal to Am, amplitude of modulating signal, into sine omega t actually, but omega suffix m into t. And it's very simple now. Now in this way here, that elaboration is given. The instantaneous value of modulating signal, the instantaneous value of modulating signal, that is information signal, is given by equation Em equal to Am into sine omega m into t. Em equal to Am into sine omega m into t. And what is this EMC here? Again, it is written clearly. It is written that instantaneous value of modulating signal into bracket information signal. So Em is instantaneous value of modulating signal, that is information signal. What is Am? Am is the amplitude of modulating signal. Am is the amplitude of modulating signal. What is omega? Omega m is equal to angular frequency of modulating signal, because everything we are talking about modulating signal. So omega m is equal to angular frequency of modulating signal. We know that omega is equal to 2 pi f. Therefore, we have written omega m is equal to 2 pi fm. So omega m is equal to 2 pi fm. So here for this, you can substitute 2 pi fm like this. 2 pi fm, and t will be there. So if you don't want to write down only omega m, then you can write down 2 pi fm, and then equation will become simple. So there is no problem. Now same thing can be done with carrier signal, because you have two signals, information signal and carrier signal. So in the process of modulation, what we are doing here, this is information signal and this is carrier signal. So in the process of modulation, we have two signals, namely information signal and carrier signal. Now we have written the equation for information signal as a Em, and now let us write the equation for what? Carrier signal. Same thing is repeated. Nothing is different. For carrier signal, what we'll do now? So here, let us see. EC. E means instantaneous value, C means carrier. Instantaneous value of carrier signal is equal to AC, amplitude of carrier signal, into sine omega t, but omega suffix c, because we are talking about carrier signal, omega c into t plus phi. And if you know omega is equal to 2 pi f, so here 2 pi f but suffix c, 2 pi f but suffix c, because this angular frequency is for carrier signal. This angular frequency is for carrier signal, and therefore equation will become very simple. EC equal to, again same AC, sine into bracket omega c, instead of that 2 pi fc, t is there only, plus phi. And here again the same things are there, but in amplitude modulation angle is not considered. Angle is not considered because only amplitude of carrier is changed. Therefore we'll remove the angle phi, and therefore EC equal to AC sine omega c into t. EC is equal to AC into sine omega c into t. And see here the same thing given here. Similarly, instantaneous value of carrier signal is given by equation EC equal to AC into sine omega c into t, where EC is equal to instantaneous value of carrier signal. Instantaneous value of carrier signal EC. AC is equal to amplitude of carrier signal. Omega c is equal to angular frequency of carrier signal. Everything we are talking about carrier signal. Omega is equal to 2 pi f. Therefore, here if you don't want to write omega c, you can substitute omega c is equal to 2 pi f c, f suffix c. And here, these are the two equations which you have to remember, equation number 2 and equation number 1. This. So you remember only these two equations, this notification, even though if you don't write, no problem, because it is understood that when you have written this equation, you know everything what is in that equation. Now we'll go to the modulated output signal. We'll go to the modulated output signal. Remember, for instantaneous value of modulating signal, we have written E suffix M. For instantaneous value of carrier signal, we written E suffix C. C for carrier. Now, for instantaneous value of output signal, we will write E out. For instantaneous value of output signal, we will write E out. And E out is equal to, again same, A. A will be amplitude. In modulating signal, we have written AM. In carrier signal, we have written AC. But here you simply write A, and we will see this A what is there. Because this A is the amplitude of modulated output, which is continuously varying or changing according to instantaneous value of information signal. So now just you simply understand, here it is written A, and then here sine omega c into t. Now you will say, sir, here why omega c? This is very important. Then here sine omega c into t. Now why here omega c came? Why not omega out? Because here it is given clear cut. Here omega c is given because the output is in the form of high frequency carrier wave. So we are not going to change the angle of carrier signal. We are not going to change the angle of carrier signal. Therefore, our modulated output is nothing but your carrier signal. Modulated output is nothing but your carrier signal. Therefore, here omega c comes in the equation of E out. In the equation of E out, omega c is there because our output is nothing but carrier signal, and only amplitude of that carrier is changing according to instantaneous value of an information signal. Therefore, this equation you have to remember very well. Omega c comes here in the output because output is nothing but high frequency carrier wave. And here, this is the reason given. But here now here, but the amplitude of modulated signal A, amplitude of modulated signal A changes according to instantaneous value of modulating signal, and that is the definition of amplitude modulation. The definition of amplitude modulation is what? Amplitude of carrier signal changes according to instantaneous value of information signal. So here it is given, but the amplitude of modulated output. What do you mean by modulated output? Modulated output is nothing but carrier wave only. Modulated output is nothing but carrier wave only. Only its amplitude is changing. So that carrier wave's amplitude changes according to instantaneous value of modulating signal. Therefore, what is this amplitude A? And say in the beginning only I have shown you. In the beginning I have shown you one this here. See. In the beginning, what I told you. In the beginning, I told you that our modulated output. This is the modulated output is having what a carrier signal. It is a carrier signal, but amplitude is changing. But amplitude is changing according to instantaneous value of information signal. Therefore, if carrier's amplitude is AC, that understand, if the carrier's amplitude is AC, then in that amplitude the instantaneous change is there. Our carrier's amplitude, if it is AC, in that amplitude there is an instantaneous change. That amplitude is instantaneously changing according to instantaneous value of information signal. So this EM is what? EM is the instantaneous value of information signal, that is modulating signal. Therefore, this equation, amplitude of modulated output, amplitude of modulated output A, if you write A is equal to AC plus EM, amplitude of modulated output A is equal to AC plus EM, and that is what here it is given. It is also clearly mentioned, and it is also given that what do you mean by capital A, which is modulated output. So here see, but the amplitude of modulated output, that is a carrier signal A, changes according to instantaneous value of modulating signal. What is instantaneous value of modulating signal? EM. We have written the equation for EM also. We have written the equation for EM, instantaneous value of modulating signal. Equation for EM is this. So here the very important thing is what? E out is equal to A into sine omega ct. Why omega c it's come? Because output is the carrier only. And here amplitude of this modulated output, A is equal to AC plus EM. And this is very important to be understood. A is the amplitude of modulated output. A is the amplitude of modulated output, and modulated output is nothing but carrier. Therefore, in the output equation, there is a sine omega ct comes carrier, and that output is changing according to instantaneous value of modulating signal. So, carrier's amplitude AC will be there, no doubt, plus EM will be there. Carrier's amplitude AC plus EM. And this is the equation number 4, which is important. And in this, if this equation number 4, and if this equation number 4, if you substitute in equation number 3, then your job becomes very simple, and this is the equation number 5. So today we are going to deal up to only equation number 5, and in the next lecture we are going to deal the rest topic. So thank you very much for watching the video. Thanks once again.